Welcome back. So following our courtroom analogy for the hypothesis test, we've created our hypotheses. In other words, both sides have entered their pleas. Now, what do we do next in a court of law? We present evidence. And our evidence in statistics is our sample. The other thing you do in a court of law is you make sure that the evidence is admissible. And we're going to make sure that our data is valid. We're going to talk about exactly what that means. Now, we're going to look at specifically the data from the Colgate ad mentioned in the earlier videos. So if you haven't already, please download that data file called Colgate. You can pause the video right now and do that. So what does it mean to check to see for validity? Well, the thing you have to understand is that the central limit theorem is kind of like the rule of law in statistics, okay? Everything is based on it. And hypothesis tests specifically have to use the central limit theorem in order to work. They're based on that. And we know that in order to use the central limit theorem, we have to satisfy two conditions. We need a good sample, which means, first of all, that the sample has to be random. Now, it's very rare in a statistical study you get an actual random sample. So generally, we settle for representative of the population. So as long as there's no reason to believe that our sample is not representative of the population, we generally assume it's okay. What would be a sample that's not representative of the population? Well, suppose I was interested in percentage of people in the US who oppose abortion. So my population is the whole United States. But I took a sample at the Republican National Convention. Okay, that's clearly not representative of the population. So that would not be a valid sample. Okay, a little bit of notation we need to recall, okay? N stands for the sample size. So when we say N equal to 30, that means that we have 30 data values from 30 individuals in our data set, or sometimes we just say a sample size of 30. Remember this notation, the Greek letter pi with the subscript 0, that's going to stand for the value that the population proportion has if the null hypothesis is true. So this is the value that we believe pi has by default before we start a hypothesis test. Okay, now we're ready to introduce the second condition for a good sample, which is that it's large enough. First of all, we take N times the sample size times the population percentage under the null hypothesis, and that's the expected number of successes in our sample, which has to be at least 10. So the way you could think of it is if you were flipping a coin, what would you assume the percentage of heads is a priori? 50%. That would be like your pi naught. If you flipped 100 times, what would be the expected number of times you would get heads? 50. Okay. And of course, you look at the expected number of successes, and that also has to be at least 10. Now, I will say there is such a thing as a sample being too large for this type of analysis. So the sample also has to be less than 10% of the population. There is such a thing as a sample being too large. There are ways that we can deal with large samples, okay? But the analysis that we're using right now will not work for samples that are too large. And the reason why is they violate this condition that the population percentage each time we draw an individual really is pi naught. When we take too many people out of the population, that changes the percentage later on down the road. Okay, important to know that if any one of these conditions that's in red is not met, we can't do the hypothesis test. This is the equivalent of evidence being inadmissible in a court of law. We have to throw it out. In our case, we have to throw out the whole hypothesis test because it depends on all of these three things being met. Okay. Now, we generally assume the sample is random unless there's something to make us seriously consider otherwise. And in the book problems, they simplify things. It's always going to be assumed. But if you're doing it in real life, like for money, you would have to look at the methodology and make sure that was true. So we definitely need to check sample size, okay? The book sometimes glosses over this. The book is sometimes kind of lazy and sloppy, and sometimes they assume it's satisfied even when the checks are not satisfied, okay? So I'm not sure how picky the book's gonna be. I know sometimes they're sloppy and they miss that. Okay, so let's go ahead and look at a word problem and kind of see how this works, okay? Let's actually apply it. So this was the problem that we had about the motorcycle injury rate. Same problem as before. And first we want to look at the wording that tells us how the sample was taken. So is this a random sample? Yes, it was. It was taken from a certain year, but there's no reason to believe that year is going to be different than any other year thereafter. So we could say, okay, what's the expected number of successes and failures? Well, remember again, for this hypothesis test, pi naught was 80% and our sample size is 500. So we plug and chug into those formulas and we find out that both the expected number of successes and failures is at least 10. What is the sample percentage? We can easily compute that out, right? 425 out of 500 individuals that were in motorcycle accidents sustained injuries. So our sample percentage is 45%. Let's look at a situation where we actually have to use a data set. Notice here, the data set was summarized. You didn't look at the raw data. You were told that out of these 500 people in some data set, 425 were in your category of interest. But sometimes you can be given the raw data too. And so we're going to look at the raw data from the Colgate ad scenario. And we're going to use StatCrunch to compute the sample percentage. So let's see how that's done in StatCrunch. So you're going to go ahead and load up the data set. Let's go ahead and do that first. So I'm going to go into StatCrunch and open it up. And I already have the data set loaded. And what we're going to do here, and you can follow along with the instructions, okay? But I'm just going to show you what the instructions actually tell you. You're going to go to Stat and Tables and Frequency. Okay. So we've done Stat Calculator for normal distribution, Stat Summary Stats when we were doing descriptive statistics for a quantitative variable, and now we're going to do Stats Table Frequency. And I'm going to choose the variable that I'm interested in. So I want the percentage of dentists in the sample that recommended Colgate. And you don't have to click on anything else. Notice that the default is frequency, relative frequency. I'm going to go ahead and click on percent of total. So actually, you do have to change this. This will give it to you as a decimal. Okay. And now we're ready. And so if we look at the percentage, okay, this is the percentage. The percentage that said yes, they did recommend Colgate was 86%. Okay. But notice, and I told you this ad was actually misleading. So Colgate had to pull this ad because there were other brands. What they did was they just asked dentists to list all of the toothpaste they would recommend, not the one they would recommend the most, okay? And if you look at some of the others, Crest ended up being recommended 94% of the time, okay? So this is why Colgate had to pull the ad. They were giving the impression it was the toothpaste that doctors recommended most, but it wasn't, okay? In neither sense of the word, because Crest was recommended more, and they also weren't the #1 ranked because they weren't asking the dentist to rank them. So a misleading ad, and there's no doubt they did that intentionally. Okay, that was intentional, the way they did that. Okay, so we have our percent, which is 86%. Okay, we can check and see, is it random? We don't know how they collected the data, but again, we're going to assume that at least they weren't that dishonest and they actually did take a random sample. Again, we know the population percentage, the sample size, they're both at least 10. The failure just makes the borderline. Okay. And so this is what we need to do when we're looking at a data set and we're examining the data. Okay. So a good thing to do in general is to, after we form the hypothesis, is to look at the sample. Check if the central limit conditions are met. Okay. You already know pi naught from forming the hypothesis earlier, and you get the sample size. It's always in the problem statement. Okay. And then compute the sample estimate from the data, or find it in the word problem if it's a summary statistic like it was in the motorcycle scenario hypothesis test. Okay, let's take a look at our reading quiz here. So what I'd like you to do is look at this problem statement. And what I want you to say, answer is whether or not the sample was random. And what is the expected number of successes and failures, and do they satisfy the central limit theorem? And finally, what is the sample percentage in this problem? So go ahead and take a couple of minutes and answer that.